All right, we're going to take a look at how to convert to a wiring diagram from a schematic. In other words, we're going to use modern real-world components to accomplish, what in a lot of cases we see is a really simplified and easy to understand ladder diagram inside of the book. So for my class there, you would have been sent out a sheet that looks like this. Now this sheet is all Schneider Components inside of here that is based around, just a ton of different components that you can basically do anything you want for motor control. We've got a three-phase motor down at the bottom, but you could go and feed from the motor into the manual starter. From the manual starter, try taking it through a forward reverse, and then down to the motor itself. You've got that available. You've got multiple contactors over here. You can do Y delta starting, make one the Y, make one the delta start. We've got a ton of control relays up top over here, just regular 8 pins. We've got a couple of timers. We have got a couple of different power supplies. We've got a DC power supply that can go along with the European standardized wiring colors that we would have there for that proximity switch. We've got a bunch of push buttons, remote stations, etc. Even a forward reversing set of contactors tied together over here. What we're going to do is we are going to work with a smaller subset. I've deleted a bunch of stuff off of this page just to get us down to a real simpler page so that it's not going to be obscured with too many lines. But we're going to try to do this figure number 6 that comes out of your electrical training binders. Now, figure number 6 is one that is specifically picked because it's going to deal with a off delay type of timer. On delay timer is really easy to go and implement with these electronic timers, but the off delay is going to be a much more difficult thing. We just roll in over here, zoom in over there, we can see that we've got 2 off delays that are going to have to be utilized. So what I've done is I've identified all the components that I'm going to need for my drawing. The first thing that I see is I'm going to need to have, obviously, some sort of a contactor set up. I see that down here in the lower right-hand side. I need a forward and a reverse to correspond with the forward and the reverse that they show over here. I see that I need to go and have 2 time delay relays. That's going to be this one and this one. So I'm going to pick these 2 as my 2 time delay relays. We also see that I'm going to need to have a forward and a reverse push button. So that's going to become these 2 push buttons over there. We see that we need a stop push button. That's easy enough to see. We got a stop push button over there. And then we see that we need an overload block. That's going to be tied in down there. And then we don't see off of here is we don't see any requirement for the power for our control circuit. Now we're going to go and step down. We're going to use a 24 volt AC control power for this utilization over here. And we're going to run our motor at the full and proper, 208 volts. I didn't identify that on the sheet, but sometimes we just have to make those mental jumps and say that's the system we're going to use because we're concerned about the controls, not so much about the motor wiring. Let's deal with the motor wiring first. What we see is we've got a bunch of terminals down over here, 1, 2, 3, 4, 5, and 6, which tells me that I've got a standard 6-lead 3-phase motor, meaning it can be configured into Y or delta. I have not given you any sort of nameplates for this one, but what we're going to say is that this thing could be configured inside of a Y type of configuration, which means that 4, 5, and 6 are going to tie together, and 1, 2, and 3 are all going to tie back to the overload block over there. So we're feeding out of our overload block to the motor, and I see that I've got these 3 leads together tied. I'll just make that actually a gray one. Note that we don't bring any sort of a neutral out to our Y types of motors. Okay, that would be bad. It has no need of that neutral. We just supply it with the 3 lines, even though the motor itself has a Y connection. The only neutrals we're grounding are supply neutrals. This is a load neutral, not a supply. That's our downstream side. Let's talk about the upstream side that we are going to go and have. We'll roll up here to our breaker. Now we've got a 3-pole breaker, which means that we are going to be feeding power from it. Red, black, and blue. That's going to be my 3 lines that I would feed down into here. Obviously, it would be done neatly, nice and squared up lines. And inside of an actual control panel, you'd have it inside a finger duct or something like that. And then what I'm going to go and have is I need to now make my interconnections on my forward reversing. Remember that my 2 standard forms of direction are either ABC rotation or CBA rotation, which we know that B stays in the same place. It's A and C that are the standard lines that are always going to go and interchange. So what I'm going to do is I'm going to go and take my lines, and I keep feeding the lines over into the same line on the top of the contact, okay? So I've gone, made all my connections underneath the terminal up top there, and moved that over so that I've got all my line 3s fed with line C, you know, and all my line 2s fed with line B, and all my line 1s fed with line A off of there. On the bottom side over here, this is usually going to be done with the use of combs inside of here, but if we don't have combs, we can do it manually as well. And what that's going to be is, remember that this overload block has got those little fingers that come off it. Those fingers are shoved up and underneath those screws over there, T1, T2, and T3. What we can do then as well is we can, since this line is passing 1 through there, we can add in another set of contacts, or another set of lines into here. I'm going to draw these ones here with a C that is going to feed into the A. In other words, if this contactor over here were to be the one that were to be closed, it would feed a line C into this line A. So A would become C at that point. I'm going to go and have my B's. They're going to go and feed across like that. And then I'm going to go and have my C's and my A's that are going to feed across like that. What we see is if that second contactor over there were to go and close in, it would interchange line A and line C, but line B would stay the same. This is the way that it is supposed to be done right and properly. All right, so that is my power supply for this over here. Relatively simple, straightforward, lines in, I'm jumping them over, I'm interchanging them on the downstream side of the contactor, and then they get picked up from there and carried all the way through the overload, no matter which one of them that I'm going to be utilizing. 1 second, just zoomed out too far. I want to just move over to this one here. All right, I've got to put this pencil down so I can actually move that line. Perfect. What we have inside of here, once again, remember that this little finger goes in underneath there, and this little finger goes in underneath there, and this little finger goes in underneath there. So when this contactor on the right-hand side is closed, my path for power for A would be coming in through there, and then it would be fed out to the line C on the motor. And if I were to go and take a look at my line B, or line C, it would be fed in through that contactor, and then it would feed into my line A of that motor there as well. So we get operation the way that we're looking for off of these. All right, I'm going to go zoom out now, and we're going to go and just nuke all of these red power lines, just so that's clear when we do the rest of our control layout. But that's the way that the power itself goes. Okay, let's examine a couple of data sheets before we start transferring this control drawing in. This control drawing is going to, oh, come on. Nope, that's the wrong one there. I rolled up one page too far. This control drawing is going to need to, just roll up, no, too far. Oh, come on. Sometimes this digital teaching drives me absolutely nuts. There we go. Move it down there. One more time. This control drawing over here does have normally closed types of contacts. Now, we've talked about inside of our apprenticeship training how we deal with a off-delay type of timer, because an off-delay type of timer has to do its timing when we remove power from it, which in the case of a pneumatic or in the case of a hydraulic timer or oil-filled dashpot timer is no problem. You know, it's the air or it's the oil that provides the timing action. But when it's an electronic timer, if we remove power, how is that thing going to go and count? So it makes things a bunch more complicated. So what we are going to need to do is change up some of our diagram up here based upon what we actually have happening inside of the data sheets for these. So let's roll over now and take a look at some data sheets. A couple data sheets that we have over here. We have got the LR, which is going to be our overload as a data sheet. We have got the contactor data sheet, and we have got the actual DIN timer data sheets. I pulled all of these up just direct off of the Schneider Electric website. Once again, the reason that they've got such funny shapes has got nothing to do with the electrical. It's because it's an unfolded box. Those are the cut lines for the cardboard that they print them on, and then these would be found by unfolding the box. They don't bother putting in an extra piece of paper. You just unfold the box to get these instructions. Looking at these really, really briefly, for my contactor over here, there's a bunch of random little things about how I can put it together, torques, how I snap on different accessories and things like that. But then down here at the bottom, we've got this wonderful little diagram that shows us that here's my coil is A1, A2, and then L1, T1, L2, T2, L3, T3. It shows me that those are all switched contacts off of that coil, as well as they show me 13, 14 is my normally open, normally closed. So that just tells me what the status is of the individual contacts on the contactor itself. I've got the same thing on this overload that is going to once again give me some little mechanical things about how to set it in, how to attach stuff, how to reset it, how to attach it to a standalone overload base. And then down over here, it gives me contact points. And it shows me that I have got a 97, 98, that when I reset it, if this thing has tripped, they're going to have changed position, but under a reset, it will open those up and close those ones up again. Same as if I press the stop button on these, that it's going to go and open at 95, 96. They're labeled as normally closed, normally open on these as well. So it's a really easy to utilize type of system. Where we get more complications is in the case of these DIN timers. Now, the first thing that we need to note is that they give us one data sheet for many types of timers, which means that we have to go and take a look at our timers that we have and make sure that they're going to go and be compatible. We have got the RE7, come on, roll up there, RE17RMMW as our specified type of timer over here. So we are going to go and find that one on this sheet over here. That's this top one over here. They give us a couple of, time delay range, time delay setting. These 1, 2, 3, 4 correspond to the English 1, 2, 3, 4 over here. That tells you about what these little dials themselves are. We'll just roll in on the dials, but basically we are going to be able to set the range, anywhere from 0.1 to 1 of a second up to 100 hours. That range then chooses how far this spreads over top. If I put this to 100 hours, then each of these would be equal to 10 hours. So this would be 10 hours, 20 hours, 30, 40, 50, 60, etc., all the way around. Whereas if I put it down to 1 to 10 hours, each of these would only become 1 hour, etc. So we set the range, then we set the time based on that range. And then over here, we have got A, H, B, C, D, I, A, C, and BW. And what those are going to be different modes that this timer is going to be set in. You want to lock these away. Once you get them set, don't let your customers screw around with it. And if you know what the mode is, I suggest pull out that Sharpie and write the mode onto there, so that the customer, if they do screw around with it, they don't leave it into a different mode, because it does completely different things when they do so. Okay, rolling down here, over here, that gives, once again, English, a couple of different things. U tells me about supply power, R is relay outputs, T is timing periods, Y1 is control contact, or we sometimes call that the input. And then TA and TR are adjustable on or off delays. They also show me that if the relay is de-energized, that it would be a white bar. If it's energized, it would be a blue bar. If an output is open, it's a white bar. If an output is closed, it's going to be a black bar. This all refers to stuff on the next page. We're going to come back to that in a second, but I do want to go back up top and take a look for those contacts. They talk about A1, 15, 18, Y1, A2, 18, 16. So this 15, 18, 16 is going to be a Form C contact, one normally open, one normally closed. The Y1 is going to be a control input, and then A1 and A2 are going to be power for this timer. Let's go now down to the second page and take a look at some of our common timing ones that we have over here. So this is going to be a really common one. Oops, sorry. Just roll to this one here, which is going to be my power on delay over here. And I just move this over a slight bit so we can see the sides there. You'll note that this is U and that this is an R. In other words, if I set that dial to A, then anytime that I apply power to the coil, that's going to be my A1, A2 contacts, that's represented by U, we saw on the previous page, then it is going to start the timing. At the end of that, it is going to activate, and then when I lose power to the coil, it's going to drop off. So it acts the same as a mechanical on-delay timer. Beautiful. Love it when my electronics can act the same. Where they start acting a little bit different is in some of these other ones, where we see a Y1, which is going to be control, and then we've got a U power over here, which is going to be just power to the actual contact itself. So we got a bunch of different modes that are going to be here. We're going to move down to mode C. I'm not going to interpret the rest of them. The other ones are some really good ones, some flasher modes and things like that. But we are going to move to this mode C, and mode C is going to be off delay with control signal over here. Does it work with what we have? Absolutely. The RMWWW, RMMW, we can do this mode. So we check that the mode is available to us. Then we are going to go and examine what it does. So taking a look at this, we see that we have to provide power to my coil. Take the coil high at all times for anything to happen underneath here. So we're going to have constant power on those lines. We see that my Y1 becomes the contact that we are going to use. If I take a look, I see that when I have got nothing applied to Y1, when I bring Y1 high all of a sudden, then what that's going to do is it's immediately going to bring my output, my relay, high. And then when I bring Y1 low, that's when it starts its off delay timing, and then it shuts off. Note that this Y1 is the only contact that we are taking high-low, but we need to have the coil powered up at all times so it can actually count, run the timer, right? Electronics without power, useless. Just semiconductors then. So that's what we're going to have to go and utilize. So that means we're going to make some modifications to that drawing that we had. Last thing that we need to do is we need to check our power. We're going to roll down over here. My RE17 RMMW over here, they give me a power diagram. They show me 15 to 16 is a normally closed, 15 to 18 is a normally open that I'm going to have. They show that my A1, A2, A1 is positive if it's DC, A2 is negative. If it's not DC, you see that little curly Q up top there? It tells me that I can go and operate this thing, from on AC as well. And if I take a look at this, it tells me that the power that I can do on DC, I can go between 12 and 240 volts DC, or I can go between 12 and 240 volts AC. In other words, this timer I can use with any type of a power supply system. And this down here tells me about the rating of that contact. That relay contact over there is good for 250 volts and 8 amps. All right. Okay, so we are 15 minutes in. We haven't even started to build our control diagram, but that's all right because we got to understand the components before we start to try to play with the components. Let's go back to this. So that's these ones over here. We're going to go and give ourselves a couple of small labels off of these, just because we want to be able to see what we have and where. I know my computer's just a little bit laggy here, but just give it a second. Perfect. We'll roll up top over here. So we got that Y1 contact. We got 15, 18. We're just going to transfer those numbers. 15 are common, 18 as being our normally open, 16 as being my normally closed. So I'm just going to go and put those lettered in up top here. 15C, and then 16, which is going to be my NC, 18, which is going to be my NO, and then I see I've got that Y1 that's up top there as well. Okay, let's now move over to this timing diagram. We have to make some modifications to this timing diagram before we can even start to go and run stuff. First of all, I'm going to examine this power. Do I want to run full 240 volt power? No, not really. If I can go with 24 volt power, something safer, lower voltage, I'm going to do that. In a lot of cases, if you got a large enough set of controls, you're going to have 24 volt power. So I'm going to start making some modifications to this right now. I'm going to call this thing 24 volts. AC that we are going to go and have. That's going to be my line. We'll call that my common. We're going to take a look at my timers. Now this 15, 18, 16, I'm going to be able to do that. That's my set of contacts coming off of that Schneider dim timer. If I take a look at that, 16 and 15 are normally closed, which is what we want for this anti-plugging. So we can go and use 15 and 16 as my normally closed. So we will go and put in those numbers up top over here because it's going to make our life easier, 15, 16. The other thing that I'm noting about this diagram is, do I need to have it interlock and then this, or could I stick them in opposite order? Absolutely, I could go and switch those two around into an opposite order. That would go and allow me to simplify my wiring because I'll be able to do my relay, my electrical interlock on the reverse, all in one location rather than having to go from the interlock back out to this timer and then back down, etc. So I'm going to also interchange those two. In my mind, I've made a couple of changes here already. These two, I'm going to switch their order around because it won't make a difference at all. It's a series type of circuit. What I'm also going to do is I'm no longer powering the coil on my timer. What I'm going to be doing is I'm going to be powering my Y1 input. So what I'll do is I'm just going to go and block off this over here. And what we usually draw for the symbol, and it sometimes doesn't allow me to draw stuff the way I want inside of this with that white blocks, but we usually draw that little arrow tab thing. And so I would label that as a Y1. I'm going to try and do that real quick over top of here, but it probably is just going to make that disappear. But that would become my Y1 for that timer 1. This one over here would become that Y1 for that timer over there. And you'll note that those little input tabs never make connection over to the return line. Okay, we don't need that return line for any of them. The other thing that we are going to go and do is we are going to take my coils for those 2 timers and we're going to add those in as well. Because we do need to add in the coil, the A1 to A2 of the first timer, and we need to add in the coil, the A1 to the A2 of the second timer as well. Okay, this is going to be T1, we'll make that one T2 over there. And that's going to be my coils themselves, the A1, A2. They will receive constant power downstream of my stop. That's my modifications. Now we can actually get into some guts of our wiring over here. Okay, so the first thing I'm going to do is I'm going to go and establish my control circuit. We'll start with that up top over here. I see I've got a single pole breaker, I've got a neutral over here, I've got a control transformer that's available to me. And that control transformer is going to roll up to it, have a little wiring diagram. Very common that control transformers will have this lined up on it already for you to go and follow through. So if I want to do my 120, what I'll see is that I can go and take one line, it doesn't matter which, it's AC, into this side here, and then following that, see that dot to dot, I got to make that connection over there. And then my neutral, it's going to get carried into there, and dot to dot. Note that I'm not grounding that transformer. This is not a supply. We are tapping off over here. So that says the high voltage side. We'll go over to our low voltage side, and our low voltage side, what we see is that we need to have a jumper across the middle in order to get 24 volts. In other words, each of these are making a 12 volt supply, so we're seriesing them together like that. And now I'm going to have 24 volts out of here fed off of those 2 terminals. What we're going to do then is we are going to go and take that and we are going to run that through my control breaker, because we do need to have some protection that's going to be on there. Now, we've only got one line running out of this thing. We have always got the option whether we want to ground. It's not necessarily a requirement for all circuits, but we've got the option for controls if we want to ground down those control circuits. I suggest doing it. In a lot of cases, it's the wise thing to do. So I'm going to do it in this case. I'm going to take my line 2 over here. We're going to call that my common. And I'm going to go and just run this thing off to ground. You're actually allowed to ground these just to the back of the can itself, a little short green jumper, and all is cool. Then I'm going to take now my ungrounded side, and I'm going to go and run that into the top side of my control breaker, and now I am ready to take power off. So these are my 2 points where I'm going to take my control power off. Right there and right there. Okay, that's now going to become that 24 volts that we talked about up top over here. Does lead us to one more issue, and that is this overload. Remember that when something is under 2506 in our code, whenever we've got a grounded control circuit, our overload can't be there, which means that we would have to move the overload up and to the far side, somewhere over there. Okay, so I'm going to go and make that change as well. Let's go and start wiring through. The first thing I'm going to do is I'm going to hit that overload from my wiring over here. So zoom out a little ways here. I'm going to identify the normally closed contacts down on this 95, 96 over here, and we're going to go to those. So I'm going to pick up my red marker, so erase that there. I'm going to run from here. I'm going to run into 95, and then out of 95, I see that the next thing that I should be picking up from my diagram is going to be, wrong page there, is going to be the stop that we need to run to. So we're going to do that next. Perfect. We're into one side of the stop, so far so good. Then from the other side of the stop, I see that I go to a whole pile of stuff. I go to all of my sealant contacts. That's 2s and 3s that they're listed on here, but we actually know that they're 13s and 14s over here. And I go to all of my start push buttons as well. So I'm going to go and make that jumper out at this point. We will go and run that with a red line here as well. Here and here. So that's going to be jumping over to the top side of my two buttons over there, as well as I'm going to go and jump down to some of my sealant contacts. I prefer to go and run from these things out to use the tops or the bottoms. It depends on which one's going to be cleaner. In this case, because we've got some electrical interlocks, it's not going to make too much of a difference to us which one we're picking. So we're going to go and take this one then to the tops of this and to the tops of this. So at this point, we have now completed that line over there. From the stop, picking up all the forwards, picking up all the interlocks, but then we've got to still continue on two more things that we need to pick up, which are going to go and be the coils of my timers over here. So I'm going to go up, A1 and A1. All right. So that now takes care of that entire line. We have got all of that tied in. Let's go and move on to the next set of contacts. So now we're going to have to identify one button as forward, the next button as reverse before we can do anything else. We're also going to have to identify a contactor as forward and reverse for this as well. So we're just going to put a big ol' F on that one. We'll stick a big ol' R on that one. And we will put this one here as being an F. And we'll put this one here as being an R. Okay, we'll just keep it with that as our layout. Let's do our forward contactor. What do I see happens on the opposite side of the forward button? I'm just picking a point to start working from. Well, I see from the opposite side of the forward that I tie to another side of my my sealant contacts. So I'm going to have to jump to the bottom side of my forward sealant contacts, as well as then I'm going to have to jump to my reverse interlock. So we're going to do that now with a different color of marker because we're getting into some, kind of new territory over here. I'm going to pick this brown and we're going to go from the forward. We are going to go into the normally closed on my reverse, right? Because forward goes into the normally closed on the reverse or up there. And then we're going to go to my normally open down over there. Let me just remake that jumper because it's got a little sloppy there. We'll run it over the top like that. That's going from my forwards or from my reverse, down into that jumper. Really, it's going like that is the order of operation. But it makes that whole set of jumpers, and then we're at our reverse normally closed contactor that we would have over there. Alternative, actually, maybe let's not do it quite like that. Well, yeah, we'll do it like that. We actually will because it won't make that much of a difference to us. I was going to reverse these two order. We won't reverse those two order. It'll be just as clean either way now that I think about it. Okay, that takes care of this set of lines that we just did over there. We'll take a look and we'll do the same for my reverse. My reverse is going to do the same thing. We're going to go from the reverse to our forward normally closed and to our reverse normally open. This one we're just going to go in a different order. We're going to go like that and then like that because it's going to make more sense on our drawing. So we'll just roll down just a tiny little bit over here. But we'll go from here, my reverse, pick up that normally open, and then we'll run from that normally open to that normally closed over there. That's the exact same thing as what we just did up there. We went from the reverse to the normally open sealant on our reverse contactor and then to the forward interlock. Beautiful? Beautiful. Awesome. Okay, so we've got that done. Next thing we're going to do is we're going to have to go and pick up our different timers. Now we're going to have to name one TD1 and we're going to have to name one TD2. It's just what we're going to be bound to at this point, or we'll just name them 1 and 2. Let's do that on these here. We'll make this one number 1. Oh, that's a terrible color to pick. Hold on, pick a better color. This is 1, and this one's going to become number 2 that we are going to go and have over there. And then we're going to now run to those sets of contacts. Okay, 1 is going to be my 1 that goes up top here. This is going to be my 2 is the one that's down here. I know that thing just has disappeared again, that little input that I drew into there. There we are. Yeah, we'll just leave that drawn over top like that. Okay, and we'll just scratch. Remember that that line over there is missing. It's just that the eraser thing on here doesn't work very well. So that's going to be my 1. That's going to be my 2 that we are going to have. Let's roll through that now. Starting from my reverse, we'll do this top line over here. We will change colors again. Disregard the colors that I'm picking at this point. It is not because of code. I'm just starting to pick different colors to make different areas more readable for us. we see that from the reverse interlock, we then go through my TD2, normally open set of contacts. So from my reverse interlock, that's going to be right over here, that normally closed, we are going to go to my normally closed up top here. I'm going to remove those letters because we don't need them so much. I'm going to take it into the common up top there. Okay, so that we have gone from there into our common up top, which is going to be number 15. And then out of number 16, we're then going to have to go down into my coil. Okay, so we're going to go and do that. So now out of 16 down here, we're going to go to my forward coil, as well as we need to go to my Y1 on number 1. So I'm actually going to do it in the reverse order. I'm going to go from here to my Y1 and then to my coil, because we're doing all of our terminals underneath there. So I'm coming out of here from my 16, and I'm going to go and take that into my Y1 up top there. And then from my Y1, so we did that into the Y1, then we're going to go into my forward coil over there. Perfect. So that now takes care of that up to that point. The very last thing that we would need to do is we would need to take that coil home on that contactor. We'll deal with taking all the coils home afterwards. We're going to do the same thing that we just did right now on this line over here. So now we're going to go and work from our normally closed forward interlock that we have to go and run to my 15 on my number 1 timer. See, that's TD1 over there. So my normally closed from here, we're going to change colors. I'm going to make this one pink. We'll run from there up to that Y1. Let me just redo that one, or sorry, up to that 16. I made that one a bit sloppy. All right, so we run up to that one on the one side, then we come out of the other side. So that's just that chunk there that we did. Now we're going to come out of the other side, and we're going to do the same thing. We're going to first go and pick up our Y1, then we're going to go to our reverse coil. So I'm going to come out of the other side, 16. I'm going to go and pick up my Y1. And then out of my Y1, we are then going to go down to my coil. Go down there with that really nice watermelon color. Beautiful. All right, so now we have got everything up to there. The last thing we need to do is we need to go and tie the back end of all of my coils together so that I have got, proper operation. Now, obviously all these timers need to have their back end tied in, and all of these coils need to have their back end tied in as well. That's just going to be all of my A2s, which are then going to get brought home. So we'll just roll up here. We'll grab a black line from there, and we're just going to jump through all of our A2s. Coming through from there, we're going to go into that A2, and then from that A2, we're going to go into that A2, and then from that A2, we're then going to go in and up to that A2, and then from that A2, we're going to go in and up to that A2 over there. And that's it. We have now successfully, it's sloppy because I was just drawing through this fast and explaining as I was going, but we have drawn through our entire timing circuit. We've modified what we had for our initial one inside of there so that we could run it with an off delay. Off delay timers are the most complicated ones to go and lay out because we have to maintain power on the coil. Note how we got this red line over here. It has power on the coil as long as nobody's pressed the stop button. It is always going to have power on the A1, and it is always going to go and have, if I trace that black line through, brought back to my common on my 12-volt control over there. So power to these at all times, and instead of us switching the coil on these, we're just switching the Y1 inputs for these. All right, that's a lot of lines to go and trace through and follow through. We did erase, the motor power conductors that were in the back there, just because it otherwise gets such a hairy mess when I'm sketching through really quick like this, but that's transference of one to the other. Make sure, anytime that you're trying to do these, that you are reading your timing diagrams up top here properly. Most common ones, as I said before, are going to go and be, the power on delay. That's a really common one to use an on delay that we will use. The power off delay is a really common one to go and use as well. Other ones that are really nice to go and use are these ones here, which is an on and an off delay. In other words, for stuff like we looked at yesterday for some of those motors that we were dealing with, this would be beautiful for staggering together a couple of motors, because you would be able to delay the second motor coming on, but you would also be able to delay that same motor going back off. So they all start in sequence and then they would all shut off in sequence through that. So that one's a really good one. The other ones that we are going to have that are really good are pulses. Pulse delayed relays are where every time that we press the button, whether it's a short press, note that this Y1 is my control input, or whether it's a long press, I'm able to get a specific amount of time out. Let's say you have a motor that always needs to operate for 10 minutes. You know, it's a pump motor or something like that. Somebody can give it a quick press, or somebody can give it a long press. It doesn't matter. You'd get a 10-minute pulse of speed out, or pulse of operation out of it. Then we have also got, just let me go down here, there is the symmetrical flasher. Another really common one, so D or DI is going to be a symmetrical flasher. We use that oftentimes to, run lights and stuff like that, where we're going to have a warning light that goes tick on, tick off, tick on, tick off. As soon as we bring that control signal high, this thing is then going to go and start flashing whatever we have off of there. Or it could be, time on, time off if it's a pump or something like that too. So you can set a duty cycle, etc. But you don't have individual times. It's the same amount of time. If this is 1 minute, this would have to be 1 minute as well. Yeah, and you got the option between D and DI. This one starts with it off. So when it gets energized, it's off, and then it waits, and then it starts. Whereas this one over here starts with it on. We energize it, and it's immediately on, and then it goes off, and then it goes on, off, etc. All right, that is it then for what I need to go run through with you. That should, at this point, give you, I know it's a confusing and tough thing to pick up, but we're in third year here, but it gives you a run through on transferring. This is what you need to do to be able to hit those ITA guidelines and to be successful in the field. All right, cheers.